Alright, welcome to our first video of our virtual classroom. We've done this before whenever we have subs, so this should not be new. You guys need to be taking it more serious though than when we have subs, because we won't be meeting in person anytime soon. So our goal today is to go over simplifying and verifying identities just a little bit more. So Monday, you are watching this video. Tuesday, we'll be meeting in real life, Q&A video chat. We're gonna try it through Zoom. So I like the features that it has a little bit more than Google Classroom Meet, but we'll try it out, see how it works. Answer questions from today and any other previous homeworks, because Wednesday, you are going to have that quiz over the identities, and that was our quotient, reciprocal, and Pythagorean. So you'll have some form of a quiz. I will be posting a practice quiz that we can go over tomorrow during our Q&A as well, that you guys should be getting prepared for. I don't know if the quiz is going to be you just do it on a piece of paper and then email it to me or post it on Google Classroom, or if you're going to be doing something a little bit more intense, like you do it out and explain it to me verbally. I haven't figured it out yet. I'm talking to some other teachers about what they plan on doing, specifically Sanford, so that way everything's kind of evened out over the different pre-calc classes. But what we're going to do right now, if you happen to bring your book home, we're on page 292. If not, I posted the problems we're working from. They're on page 292. We're going to be looking at 17 through 26. We're going to see how long this takes. I plan not to post videos much longer than a half an hour. So we are looking at number 17. All right, that's our first one. We have tangent squared theta over secant theta minus 1. We want to simplify this. Remember what we said, what simplify means. It is to write it hopefully without a fraction, hopefully with sine and cosine, or at least any one trig function. And we say two different trig functions here. We see a fraction that we don't like, and we're trying to figure this out. Unfortunately, this is the ones that I really don't like, and I probably will make sure they're not on the quiz. We have to create a Pythagorean identity here. So the way that we do this is we want secant squared, and then we want minus 1. If we do this on the bottom, we will get secant squared theta, and then we make this a plus 1. We will have positive secant, negative secant, which will cancel out, and then we just have minus 1, because 1 times 1 is 1. On the top, however, we get something a little bit weird, and we're just not even going to bother trying to simplify it quite yet. We'll see what happens. Remember, we multiply the top and the bottom by just secant theta plus 1. All right, so now we have to think to ourselves, what do we have? I did that on purpose. I mentioned Pythagorean identity. So the top stays the same. All right, but then on the bottom, we can use our Pythagorean identity to say that's tangent squared, which these tangents squared out, they divide out, so we're left with just secant theta plus 1. Is that more simplified? Yes, right? No fraction, only one trig identity, nothing too complicated. After that, we just have secant theta plus 1. Usually we like it going down to 0 or 1 or something that has, no trig in it at all, but we can't be picky. So we're going to move on to the next one, which would be number 18. All I was just checking my answer to be safe. All right. 18. See, it didn't even take out that much space. 18. We have cosine theta times secant theta plus tangent theta. This one is looking crazy, right? So what we're going to have to do is, again, we don't see anything that we can do too easily with changing it to sine or cosine. No, let's actually try that, actually. So let's do that. I was going to say maybe we can put it in Pythagorean identity, but that's always more difficult. Let's just write it in the reciprocal form, right? And then using the quotient identity, write the second one. So when we look at this, I was thinking we're going to have to use Pythagorean identity. But this is actually going to end up being a little bit easier because we do have the same denominator here. So we have the same denominator. So Donovan, he would usually say, make sure the denominators are the same or find the least common denominator. They're already the same denominator. So we can just add across, right? So the top becomes 1 plus sine cosine. 1 plus sine theta. And the bottom we have cosine theta. If we multiply this all across, we have cosine theta times 1 plus sine theta. And then on the bottom of both of them, right, because this is the invisible one, we have cosine theta, which means these cancel out. So we are just left with, at the end, 1 plus sine theta, which would be our final answer. Wouldn't be too hard to get there either. So let's move on to the next one, number 19. We have 1 plus cotangent theta, cotangent squared theta divided by secant squared theta. I left my blue paper at school. I don't feel like Google searching this, so let's try to rearrange and get to what our Pythagorean identity was. We have sine squared theta plus cosine squared theta equals 1. That's easy enough for me to memorize. We want to see if this 1 plus cotangent is anything. Cotangent is not sine over cosine, it's cosine over sine. So let's divide everything by sine to see what we get. So we get 1 plus cotangent squared theta. And then over here we have cosecant squared theta. So we did get what we wanted, what we had. So we can rewrite that as cosecant squared theta over secant squared theta. I still see two trig functions here. I don't like two trig functions. So we can do the classic thing of just rewriting it as the reciprocal. So we have 1 over sine squared on top, divided by 1 over cosine squared on the bottom. We don't like fractions and a fraction, so we do 1 over sine, which is the top, multiplied by its reciprocal, right? And then we multiply across. So we get cosine squared of theta divided by sine squared of theta. And somehow we come back to almost what we had there a little bit, which is cotangent squared. So there is tons of different ways to do this. I don't want to overcomplicate this by looking at other ways, but maybe you see the other way we could have done that to get to this a little bit faster. But whatever, our final answer is cotangent squared theta. All right, number 20. Which is our last simplifying. We have cosine squared x times sine x plus sine to the third x. This one is crazy. So let's see what happens. If we start looking at this, there's not much we can do with Pythagorean theorem yet because we see cubes. We can't really rewrite cosine and sine as anything because they're already that. But what we can see is that in each of these, we have a sine. So let's factor that out. We have sine x. If I take that out of the first term, I'm left with cosine x. If I take one sine out of the second term, instead of sine cubed, it's going to go down to sine squared. So just by factoring it out, things get a little bit more simplified, right? What is cosine squared plus sine squared? If you are really puzzled about that, we can rewrite it in just the other direction, which is fine because it's addition. And we have our Pythagorean identity. So we have sine x times 1, which is just sine x. So it simplifies down to just sine x, and we're done. So we're moving on to number 21. 21 from page 292 is verifying each identity. So remember, this is one where we have two sides of the equation. We need to decide which side of the equation is more complex, and then we try to get to that side. Usually by more complex, we mean we see fractions or we see some crazy stuff. So let's look at this. First thing, we should realize that this is the more complex side because of the fractions. We should also see that they do not have the same denominator. So if we were in our Q&A with Zoom tomorrow, I'm sure if I asked this question, Donovan would raise his hand, which is a button on Zoom. Least common denominator, right? Here, too much thinking, let's just multiply the two denominators together. So here's our original. Here's our original fraction. To get to the same denominator, we multiply the two denominators together. But whatever we do to the bottom, we must do to the top. All right, so we do that to the other one too. We have 1 over 1 minus cosine x. This one time we multiply by the other denominator, which is cosine 1 plus cosine x. Whatever we do to the bottom, we have to do to the top. So that's how we get that. So now we have these two fractions. We know that the denominator is going to be the same. So that's going to be 1 plus cosine x, 1 minus cosine x. But then on the top, we get 1 minus cosine x minus 1 minus cosine x. So these ones add up to 0, but then we're left with negative 2 cosine x, and then we have all this other stuff on the bottom of a fraction. So let's actually FOIL this out. On the bottom, we get 1 first, outer is minus cosine x, inner plus cosine x, last minus cosine squared x. So these add up to 0, so we get negative 2 cosine x divided by 1 minus cosine squared x. Which looks like something, right? Because we have a square and we have a minus or addition. So let's, again, start with our memorized Pythagorean identity and rearrange it. We want 1 minus. So we can minus cosine on both sides, which would mean we have sine squared, and we can replace the theta with x, and then 1 minus cosine squared x. So if we go back down here, we can rewrite the bottom as 2 cosine x over, and this would be sine squared x. We don't want this fraction. All right, we are desperate not to have this fraction. And we do have cosine over sine, which we can turn into tangent, cotangent, but that would only be one of the sines. So we still have that other sign on the bottom by itself. So we'd have negative 2 cotangent x times cosecant x. So that would be our final answer. Not really the more simplified, but it is technically more simplified. And we're going to move on to a new page because that one was quite long. So that was a long one. I don't want this video to go on too much longer. We are about that halfway mark. So let's try one that's not a fraction. So let's jump. Oh, they're all fractions here. Let's jump to number 24. All right. We have tangent of x times secant squared x equals, minus tangent to the q power x equals secant x over cosecant x. Again, we're not trying to say one side is the most simplified. We're trying to say which one is more complex and which one do we start with. Again, I think the book usually puts us on the left, so this is the one. Just like the one that we did with simplification, we see tangent repeated, right? There's a tangent right here, and there's a couple tangents right here. So let's try to factor that out. If we factor tangent out of the first term, we're left with secant squared x. And then over on the other side, if we take one tangent out, we still have 2 left. All right, so now we need to think to ourselves, this looks like a Pythagorean theorem, a Pythagorean identity, but we don't remember it. So again, we start with the original one that we had memorized because it's easier than all the others. But let's try to rearrange this. First, we want secant and tangent. So if we want tangent, we have to divide cosine. We have to divide sine by cosine. So that means we have to divide everything by cosine squared. So here we get tangent squared. Here we get 1, and then here we get secant. So we want secant squared minus tangent. So then we minus tangent on both sides. So we get 1 is equal to secant squared theta minus tangent squared theta. So when we come back to this, we know this whole thing is just equal to 1. So then we have tangent x. But that's not what we're going for, right? So we have to keep working even though we got to the most simplified thing. So tangent, using the quotient rule, we know we can do sine x over cosine x. But then we're still not, because we want secant and cosecant. So let's use our reciprocal identities. Sine is 1 over cosecant. Cosine is 1 over secant. And now we have this jumbled up fraction. So let's separate them, right? We can, if we have 2 fractions, we can take the numerator and divide by the reciprocal of the denominator. So that means we get this for our second part. And then we just have 1 on the bottom. So when we multiply these 2 fractions together, we get secant x over cosecant x, and that is what we're trying to get. So that does verify. This one was a weird one because we're trying to get it from something that was complex. We got it to a very simplified version, and then we had to kind of mess it up a little bit. So let's go on to 25, which does look a little bit weird, but I'm hoping that it doesn't take too long. So let's see. It looks promising, though. This is just taking a while to write. All over, scary fraction bar, and that is a 3 equals cosine x. So first things first, we see a lot of trig being added together. Let's look for a Pythagorean identity. I see it, but it's being separated. So maybe let's just rewrite it together. Right, we're just rearranging stuff at this point, not using any identities yet. Oh, when we're doing verifications, we don't need to rewrite the right hand side down because we're keeping this. That's what we're shooting for. So this part right here, we know that's equal to 1. All right, we know that's equal to 1. And now we want to figure out, we still have 1 plus tangent. And I believe we figured out what that is. 1 plus tangent is equal to secant. So the whole top of this using Pythagorean identity turns into secant. So we have this, the top 2, take away 2 from the bottom. So we're left with just secant x on the bottom. Is that what we're going for? No, because we can use the reciprocal property, the reciprocal identity to get cosine of x. So we did get them to match, right? These are equal to each other. So we're good. We verified that. So that was the last verification problem. Number 26 was just which one is not equivalent. So we have this one right here. And we're getting asked which one is not equivalent out of our multiple choice. So there's a couple ways to do this. we can look at our answer choices and actually figure out which is just equivalent there. Because if only one of these is not equivalent to our original, that means the other three are equivalent, which means they're also equivalent to each other. So this might not actually be that bad, even though it gets us started a bit weird. All right. Right, so we do have sine and cosecant, which we have these two reciprocal identities, which say they're related to each other, but they're the reciprocals of each other. So if we look at B and C, B and C is our cosecant reciprocal. So these are equivalent, so they can't be the correct answer, right? So now we're just left with the other two. If we have sine over cosecant, right? Sine over cosecant, that would be sine over 1 over sine, which would be sine times the reciprocal, which would be sine squared, which is not the same as anything, right? So this might actually be the right answer. So let's just check D. We have sine theta cosecant squared, which we can rewrite using our reciprocal property. 1 over sine squared, right? And then this square and this sine would cancel out. So we're left with 1 over sine, which is the same as B, right? So these all three are the same thing. And if we go back to our original now, and maybe we're too scared off by this, right? We have 1 plus cotangent squared. And if we go back to one of our other reworks of our Pythagorean identity, we do have 1 plus cotangent squared equals cosecant squared. So if we go back to the problem, this is cosecant squared theta on the top, cosecant theta on the bottom, right? This would cancel out the square part, so we're left with cosecant theta, which again is C. So A is the one that is not equivalent to all the others. So that's just about it. You can see the practice quiz online and see what it's going to look like. Not a lot of multiple choice answers here, so we'll be somehow creating the actual work and submitting it to me for your quiz on Wednesday. We'll discuss more tomorrow in our Q&A. See you tomorrow. Don't forget to download Zoom, sign into it, and just get in so that way on Tuesday, tomorrow, when you try getting in right at 11:16 is when the Q&A is going to start, with or without you. It'll be there and you'll be ready to get in. I will save the Q&A, but if no one's there to ask questions, I'm either just going to talk to myself for 52 minutes or I'm just not going to do anything. And then all of you will have a quiz problem or a few quiz problems to do on Wednesday without having a lot of practice. But I will see you tomorrow in the Zoom. Good luck on the practice quiz. Goodbye.